Hi, I'm Amir Hossein Mirza Bozorg, and in this video I want to talk about sandwich panel and honeycomb analysis part 1. This is the table of content. I will talk about defining the geometry of honeycomb, defining mechanical behavior of honeycomb, choosing appropriate step and solver, defining interactions in sandwich panel, and defining the mesh of honeycomb. Honeycombs are metallic, thin-walled structures that improve the loading capacity of structures against dynamic and quasi-static loadings. Honeycombs can have various patterns and design. According to their usage, the appropriate design must be chosen. Simulation of these structures helps us to select the best design and pattern. For getting correct results from the simulation, you must consider several points that are vital. In this tutorial, several aspects of modeling and simulation of honeycomb in sandwich panels are discussed in detail. This tutorial includes defining the geometry of honeycomb, defining mechanical behavior of honeycomb, choosing appropriate step and solver, defining interactions in sandwich panel, and finally defining the mesh of honeycomb. Now I want to talk about defining the geometry of honeycomb. As the honeycomb is a thin-walled structure, it must be modeled as a 3D conventional shell. Here, I have created the geometry of this honeycomb. I have defined a 3D deformable shell, and I have used extrusion technique for creating the honeycomb. And this is the sketch of the section of the honeycomb. And by extruding this sketch, the honeycomb is created. I want to show you these settings in Abaqus. I go to model tree of model 1, honeycomb, features, shell extrude, section sketch, and you can see this sketch. By extruding this sketch, the honeycomb is created. Now I go back to the slides. I want to talk about defining mechanical behavior of honeycomb. As the honeycomb is made of metals, elastic and plastic behaviors must be defined for it. If the loading is static or quasi-static, for example in 3 and 4 point bending test, the hardening of plastic behavior must be set on isotropic or Johnson-Cook model without definition of rate dependency. If the loading is dynamic, like blast loading, isotropic or Johnson-Cook model with rate dependency must be defined. Here I have defined a material named ST. ST is the abbreviation of steel. I have defined elastic behavior, plastic behavior, and I have defined rate dependency. I have selected Johnson-Cook model for plastic hardening, and I have defined Johnson-Cook rate dependency model. Now I want to show you these settings in Abaqus. I go to property module, as this analysis is a mechanical analysis and not a thermomechanical analysis, I have set the melting temp and transition temp equal to 0. And even I can set the M coefficient equal to 0, 2. Because there is no need for these constants in mechanical analysis. Here I have defined the rate dependency and I have used Johnson-Cook model. Now I want to talk about choosing appropriate step and solver. As the loading increases, some of the cells of honeycomb may buckle, so large deformation will occur in the simulation. This leads to the increase of degree of nonlinearity of the simulation. For having faster simulation, it is better to use dynamic explicit step even for static and quasi-static loadings. Actually, the degree of nonlinearity of this simulation does not make any issues for the dynamic explicit step, but if a static general step or dynamic implicit step are used, the convergency issues may arise and simulation faces too many atom error or minimum time increment error. Here you can see the buckling and large deformation of walls of honeycomb. The honeycomb is subjected to dynamic loading. I want to show you the settings of a step module in Abaqus. I have defined a dynamic explicit step. The NLGEM is set to on because we have large deformation, and as the simulation is dynamic, I have defined a short time period. Now I want to talk about defining interactions in sandwich panel. Usually, tie constraint is defined between the honeycomb edges and top and bottom plates. In some cases, due to extra loading, the honeycomb will have contact with the top and bottom plates or with itself. The best choice for modeling all of these possible contacts is general contact method. By defining the general contact, the contact between all of the external faces of the elements will be defined. In this picture, I have defined tie constraint between the bottom edges of the honeycomb and the top surface of bottom plate. And here I have defined general contact for including all of the possible contacts in the simulation. And I have set it to all with self. Now I want to show you these settings in Abaqus. I have defined the general contact and I have used conwep method for defining the blast loading. And here I have defined two tie constraints. I want to talk about defining the mesh of honeycomb. As the honeycomb is always created by using 3D shells, it can be easily meshed by using quad elements. Because of buckling of the cells, the size of elements along the height direction must be less than the size of elements in the horizontal direction. In this mesh, I have used quad elements and I have used free technique and advancing front algorithm. And I have set it to create mapped mesh. Here you can see the mapped mesh and the size of elements in the height direction is half of the size of elements in the horizontal directions. Here the size of elements in the height direction and in the horizontal directions are the same. But in this mesh, the size of elements in the height direction is half of the size of elements in the horizontal directions. And I have performed the analysis by using both of these meshes and I have compared them. Here you can see the deformation of honeycomb. And in this case, more accurate deformation is simulated. But here it is not enough accurate and you can see the difference. I want to show you both of these results in Abaqus. Here you can see the difference between the deformation of small elements and bigger elements. You can contact me by using Telegram or WhatsApp, and you can send email to me. We can have one-on-one tutoring on the AnyDesk WhatsApp, and I can make special videos to your order. We can perform high-quality simulations for your thesis, exercises, and industrial projects. Thank you so much for watching this video. Goodbye.